So you'll always be able to access the class recordings and whatever happens in here. And I don't take attendance because it's up to you. You know, you figure it out. If you miss something, that's not great. But this I'm running this so much differently than I've run any class before. So if you've had a class with me, welcome to a new style of class. Camila, like, she was already in on this because we had a real analysis together this morning. And Kristen as well, yeah. So instead of having tests and homework and stuff like that, I'm gonna be trying to use what's called mastery grading this semester. How many people have had that experience with mastery grading? Yeah, and I'm not gonna ask if you like it or not, because it's honestly too late to change it. It's just like, I'm kind of freaked out by it. And I actually literally scaled back what I was going to ask you to do already. Like in the hour before this class, I was like, oh no, we're not doing that too. That's too much. So realize I've already made your lives easier just because it's like too much for my mind to keep together. So, if you look in the syllabus, which is up online and just got updated like literally an hour ago, content area of world class, you'll find the syllabus. Here's the basics. We meet today and Mondays and Wednesdays for 75 minutes. We also meet on Fridays. So if that's a surprise to you, I'm sorry, but we meet 4 hours. So we'll meet on Fridays for like 50 minutes or something like that. And then Fridays will have a special importance that I'll explain in just a minute. So how are you gonna get a grade in this class? Let's just get this shit out of the way so we can do it. So I'm gonna give you 23 problem sets to work. Yeah, it's a lot. That's what I thought. I thought that seems like enough already. So I'm gonna give you 23 problem sets to work, and you will have to work them in class on Fridays. And so we've got some designated Fridays to get this stuff done. So they're kind of like quizzes, but they're open note. You can like look stuff up. You want to master the material. So we'll take, not this Friday, but next Friday will be our first one. We'll take that day. I'll give you as many as you can possibly work in that time frame. We'll just sit here and we'll all work on them, and then I'll take them home and get a satisfactory, could be better, are you kidding me? You'll get 1 of 3 grades on it. And if you get like, or this, you rework it until you get this. So you get to rework things, and that'll happen when we do it together. So if you need to make up something, like you want to redo one of them, we can set up a time and meet outside of class, but it all kind of has to be proctored in a way so that ChatGPT isn't doing it for you, you know. I mean, the temptation is strong. So we'll have 23 of those problem sets, and you just need to get a thumbs up on, I think it's 19 of them to get an A. So we have this basic scale. This is one component of the grade. It's like roughly like 90%, 80%, 70%. And you can look in the syllabus for the exact number of problems you need to get a thumbs up on to get the grade you want. And so it's really under your control, right? Like, you can work as hard as you want to get the grade that you want. And if you're just like, you know, a C is just fine for me, cool. I'm not gonna try to push you to do anything else. It's up to you, you choose. Then this part's gonna be tricky. There's gonna be these little quizzes you have to study for before class. So they're like warm-ups before class. The first one happens a week from this Wednesday. So your first prep quiz, we'll call them prep quizzes, will be, could somebody maybe just on a calendar, what is the number that's next Wednesday?
22nd.
Thank you. First prep quiz is due before class, January 22nd. And then we'll have one like every day, roughly. And these are online in world class. These you cannot redo. But there's some laps. So like to get an A, you have to do whatever the requisite number is of these. I'm pretty sure it's 19. And then your quiz score, we'll call them quizzes, the prep quiz, you need to get an 85% or better for the semester, and this many problems done to get an A, and then a certain number down here. See, that's not even like an A, right? That's not even like 90%, it's not the classic A, so there's some slack built in. Because sometimes you're just gonna forget, and sometimes you're just not gonna wanna do it. So, but these cannot be made up. I will not extend these. And I'd kind of like you to just respect that and please not ask me to extend it. That's all I ask. I'll give you yards of slack and just please don't ask me to do that. Does this sound okay? Cool. All right, thanks. I appreciate that. And I think that's about it. You can decide what you want to do in the class. There will also be web work problems. Not required, but highly recommended. So right now, there is a web work assignment that is open right now. So we have web work. Up to you. I'm not gonna look at it. I'm not gonna be passive aggressive about it. That's kind of like my MO previously. I would come in and be passive aggressive about how many problems people have done and so forth. And it's like, I'm not gonna have this, it's up to you. But we can talk about them in class. If you look in World Class in the announcements, you can find login information there for how to get to it. And I think, I don't know, did you have World Class open? Is it up already?
Yeah.
Yes, fantastic. So please do this before, like, I don't know, the end of the week. Just make sure you can log in and that I entered your credentials properly and all that kind of stuff. And you can start practicing early. This first week is warm up. We're in calculus boot camp this week. There won't be any quizzes on this. There's just the web work, and we're gonna work together to get this shit in order. Does this sound okay? So just think to yourself, okay, what's the first thing I have to do? The first graded thing you have to do is next Wednesday. Before next Wednesday, just do that quiz. You'll have to read the book. Got a link to it in the content area. You'll have to read a section of the book, figure it out. I think it's on like compound interest. It's chill, but you'll have to figure that stuff out. So do the things you do to figure things out, right? YouTube, ask me. If you look at it early enough, we can talk about it in class and I'm happy to help you. Does this all sound good? Cool. My office hours are Monday, Wednesday, and Friday right before this class. Pretty much 12:30 to 2 all those days. Thursdays, I don't have official office hours, but I'm happy to meet with you. And I don't know when I'm going to be in on Thursdays yet, but I will be in. And maybe just let me know if you want to meet. We'll figure it out. I'll be here to help you, or I'll be on Zoom to help you. I'll help you. That's the long and short of it. Any questions on like the bureaucracy of how this rolls? Kind of a change, kind of a sea change for me. So I'll tell you what. I was talking to Cybert about this. And I kind of grabbed this structure from him because I've never done this kind of grading before. And he said, oh, are you going to do the projects? And I was like, yeah. And he's like, oh, I wasn't sure I was going to do those the first time. And I was like, you know what? We're not going to do those either. So I went to the syllabus and just hacked out this whole section on these 5 projects I was going to ask you to do because I just can't handle all this newness, frankly. I like change, it's all cool, but I figured you wouldn't be upset. No, nobody's upset? Cool. All right, great. And maybe we can make those like some kind of extra credit or something. I don't know. We'll figure it out. But this is all we're going to do. I think it's nice and straightforward. And there's no stress of the exams, right? And I think I set it up so you can rework these pretty much as many times as you need to get a perfect score. Within reason, I mean, if we're still working on week 1 stuff on week 7, maybe we should talk. All right, let's get rolling. Let's start talking about calculus. If there's no questions. Are you good, Daniel? What's
Voice.
noise.
What is?
The noise.
Oh, the noise. Yeah, it's hideous. Yeah, apologies. I don't know what else to do. Use my shirt, spit on it.
Your face.
Yeah, exactly. Yeah. So let's just kind of let's start off chill. And I'm going to ask you guys questions. And actually, let's make a little seating chart real quick, just to help me memorize everybody's name and context of who's all here. Who would volunteer to make a little replica of this table for me? Thank you. That was a good way to volunteer.
I'm gonna make a worse one for you.
Oh, thanks. And just if you could just put on there what you'd like to be called. You don't have to put your everybody's.
Usually pass around.
Yeah.
True.
And if you and also please put your pronouns on there. Please. Mine are he, his, him. Please put your pronouns on there. Cool. So I've got some kind of input and I've got some kind of output. And I've got a picture because I took some data and I made a picture out of it, relating the input values to the output values. What do we call that?
Graph.
Graph, cool. Yeah, I like that. We'll start there. Graph. What could I say about this in relation to this?
The output values are a function of the input
Ooh, I
values.
like that. Yeah. So we've got a function. The output is a function of the input. It depends on the input. So the output is a function of the input. And we're going to start making this mathy. Does this notation look okay except for the weird words? What are some more common variables I would use? What's a common variable for the output axis?
Y.
Thank you. Y. What about input?
X.
X. What about science folk? What do you sometimes use instead of X?
Z.
Oh, what?
Dependent and independent?
Ooh, I like that too. That's also nice. They also put that. I was thinking of a letter, but I like that. So this is independent and this is dependent. Damn, that's good. So like X, what's another one science folks use just a lot?
Z.
T?
With Z.
Z? Ooh, really? Nice.
Yeah.
No, that's cool. No, that's cool. I've never thought of that. We can use whatever we want. I guess I was thinking T for time.
Oh. Okay.
Does that make sense? Like kind of time, we have phenomena that depend on time, they change with time. So often, we're gonna save Z for something special because soon we'll be doing 3D stuff. We're gonna hold on to that Z. So input X and sometimes T, and we're gonna use T a lot in here because there's a lot of science folks in here. You're either a science folk or you're a math folk and you have to take this class for some reason. So when I say this thing is Y depends on the input values of X, I've established a relationship there that I call a function. What does this mean? Which is this. What does that mean? Derivative, yes. So this is the derivative of f with respect to the input variable x. What does that mean? Slope. Yeah, slope of a tangent line. I gotta get everybody's name so I can start spreading out the love here. Make sure everybody's having fun. But this is equal to the slope of the tangent line to the graph y equals f of x at x. Let's think about this a little bit more. How am I going to get that? Let's pick an x. Some of this I just want us to review so we see it. Because what we're going to do in this class is take everything you know from Calc 1, Calc 2, mostly Calc 1 honestly, and make it multivariables. So if we can understand, and the cool thing is, once we kind of remember how to do it in one, it's just kind of doing it in different dimensions, the same thing. So once we remember these processes, we can extend them to higher dimensions. So what I'm going to do is I'm going to move over h units, or delta x, maybe change in x. I'm going to change the input value just a little bit. So if I move over h, this is x plus h. And that changes the output. So here was my original input, or output. When we had input value x, I came out with value f of x. When I put in this new one, I come out with value f of x plus h. And so you please stop me and ask at any time, because it's super important that we remember this. And that maybe it grows even a little deeper roots, right? We're trying to like nurture all that stuff. So the slope of the secant line through those 2 points, so slope of the secant line through x comma f of x, that first point, and that new point, which is a perturbation of this one. So we're slightly tweaking this input, and it changed the output to this value. The slope of that secant line is the change in the f over the change in the input. So change in output over change in input. It's the average rate of change over that x range. So this is equal to the new value output minus the original over the amount the input changed, which is just h. Now, does that look familiar? Check that out. And hopefully that kind of rings some ancient bells. Yeah? And maybe you even reviewed all sorts of calculus over the break. Maybe you did that. And this is easy. We got this. So what we're going to do is we're going to let this point slide toward this one, because what we're interested in is what happens when h is really small. What happens when I just have a slight tweak here? What happens up here? So we're going to let that shrink to nothing. And what I do then is I say that I'm going to take the limit as h goes to 0 of this quantity over this quantity. And that, my friends, is also that thing there. That is the definition of the first derivative at x. So hopefully, there's parts of you. If you've never seen this, that's another thing we should talk about. It's going to be a very painful semester. But everybody's seen this, right? Cool. Love it. So, I'm not going to ask you to do this. Not right away. Not until we have more variables to make it eviler. We won't do limits until we have more variables, because then it gets weird and disturbing. And I mean, one of the cool things about math is there's weird and disturbing things all over the place. And that's where the joy comes. That's what always kept me going as a mathematician. Pathological things. We have that word pathology in math, and it just means weird shit is happening. It looks weird. It acts weird. And what else can we hope for in life? So we're not going to do it by that definition. We got all these rules. So let's see what we remember. And this, I have to give you the master sheet, I think. I have a master sheet of calculus facts that I need to put up for you. But let's see what we can remember today. So this word calculus means method. And you can use that. So like if you want to be cool in some other class, like an English class or something, toss this in when you're like talking about figuring something out. The calculus of Joyce or something crazy like that. Just say it. Just say it. The English people, they're up for that. They want that. You're in a poetry class, use this word. The calculus of reason, whatever. So what we're going to start talking about today, and just today we're going to do differential calculus. This is the method of taking derivatives. which turns out to be nothing as hideous as this seems to be. There's actually really cool rules, right? Like it's like move an exponent down, and I did that. That's crazy. That's awesome. So let's talk about just some of the basics. First off, if I take the derivative of the sum or difference of two things, it's the sum or difference of the derivatives. So I'm going to use two different kinds of notation here. Instead of saying d dxf, I'm going to write this. Instead of saying d dxg, I'm going to do this. That's one great property, that you can just do the derivative to each of the pieces in a sum and not worry about it. And then we also have this other one. That if I have a constant, and I know the derivative of this, but I got a k in front of it, I just forget about the k. Keep it out front and do the derivative that I know. So just take the derivative on the moving part. The x is the part that's changing. This is just a constant. These two together comprise what's known as linearity of the derivative. So if you're a math person, this is for the math folks. If you're not a math folk, you don't give a shit about this, and that's fine. But if you're a math person, this is the derivative is linear. Anytime you see stuff that acts like this, that's linearity. Cool, so that's like the basics. What about, can you just take a minute on your paper? No one's gonna know what you write. Karmic free quizzes. What's that? This is times. Don't say it out loud. What's the product rule? See what you remember. So that's gonna be the product rule, and then see what you remember about this. The quotient rule. And if you're watching on video and you're playing along and you're Dr. Chamberlain, who's secretly dropping in, what do you remember about these? So this is the product rule. This is the quotient rule. We'll just take a minute. I'll let you do some stuff instead of having look at me do my show. Did that list of folks get around? Thank you, Daniel.
I don't know whose pen this is.
It's not mine either. I don't know.
It just came back to me.
Okay. It's yours?
No,
Oh, okay. It's a nice
that's
pen.
fine. This is-
Okay, this is like one of those things, unless someone's deriving it from scratch, which oh my God, I bow down to you if you're deriving this from scratch in the limit definition, because that's not easy. You either kind of know it or you don't, right? It's like one of those things you're not gonna figure out here in the next 3 minutes. So can somebody give me this one, please?
Is it F prime G
Love it.
plus F G?
Yes, ma'am, thank you, Camille. Beautiful. Each part of the derivative gets, each part of the product gets a derivative, we leave the other parts alone. Yeah, great, thank you. Anyone else care to regale us with the quotient rule? Here's a hint, the bottom is the original bottom squared. What goes on top?
G of x times f prime of x minus f of x times g prime of x.
That is solid, I love that shit. So it looks a lot like the product rule, except we got a minus. And I just commuted, I just flipped these two. Christian read g of x times f prime, same thing. I just kind of like to write it this way because I think the top gets the derivative first. leave the bottom alone, minus, oh, I did forget that. And then bottom gets the derivative there. So just make these little notes. You want to have these things handy because we're going to use them like every day. For a while, we are going to take a slight digression. Oh, did I miss something?
Did you miss the G prime of X on the product model?
Thanks.
Just
Good shit.
Make sure
Yeah,
it's-
good stuff. Hey, yes.
I'll be the Lou of this class.
Yeah. Dude, that's great. Yeah, you are. You already are. You're helping me. You're fixing me. Everything. Yeah, do the stare. Do the stare. Like.
Maybe he's gonna like check the PDFs before he does, so that they don't have viruses.
Yeah, it's true. Yeah. Luckily, no one has to steal a PDF for our textbook. It's up online in the content area. It's free, so we don't have to have illicit PDFs being handed out. Although I'm all for that. We're actually going to take a little break, probably starting next week, where we actually don't do calculus for a while. We go take a digression into vectors, and we refresh your memory about vectors, or create your memory of vectors, or just something like that. We're going to take a little vector journey. And that always gets exciting because it's higher dimensions. And I've got some good stories to tell you that I have to stay on track and not to use up our hour to tell you, but I've got a lot of shit to tell you about that. But today, we're gonna just do this stuff here. Let's see, what's this one? So we've got those two rules. What if I have a composition of two functions? Chain rule. Brandon, can you tell me how that goes? That's beautiful. I love it. Absolutely. Chain rule. Have f of g of x. How do I do that?
It's f of x, or f prime of g of x times g prime of x.
Damn, yes. Beautiful. Thank you. Yeah. Do the derivative of the outside function times the derivative of the inside function. And we're going to put these all together in just a minute. I want to give you a couple special versions of some of this stuff that you have at your ready, because you're going to need them all the time. So here's a special version of this for exponential functions. Special case. And it just looks different. It's really the same thing. If I have e, the number e, Euler's number, 2.7, 18, 28, blah, 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 blah. If I have that, and I want to take the derivative, and it's got a variable exponent, the outside is just the e part. So that stays the same. The inside is the exponent, so it's times the derivative of the exponent. And then another special case, which is the inverse of this. If I have natural log of a function, the derivative of natural log, let's make a little table of things we might need. Let's say I've got d dx natural log. What is that?
1 over X.
1 over x, nice, yeah, 1 over x, beauty. So the derivative of natural log is 1 over the thing I'm taking the log of. 1 over the thing that's inside the absolute values. So the outside derivative is 1 over the f of x times the derivative of the inside. But you can just remember this special form right here. It's a quotient. And I think we'll write up, let's just put a few others up here so we have them. So the derivative of e to the x, that's the best one in the world. Love that. That's like the lowest of the calculus fruits on the calculus tree, right? How about that one?
Cosine X.
Was it?
Cosine X.
Cosine, beautiful. And then let's just get, for our jollies, somebody else who hasn't told me the things. Negative sine x, beautiful. Thank you. It's hard to say shit the first day. Kudos to everyone saying shit the first day. And everybody will by the end of the day. All right, so let's do some practice. Let's do some derivatives. So I'd like you to just take a minute and do these. So let's do e to the negative 3x. Oh, one last rule probably that you don't remember necessarily. What's the power rule? We need that.
You bring it down and subtract the exponent?
That's, yes, more precisely. Yeah, so, and the exponent comes out front like Daniel said, and then you subtract one from, yeah, exactly, yeah. You were saying, I knew you knew what it was, I just wanted to get the right formula. That's beautiful.
Sometimes blanks in my mind anyways.
No, you did good, you did good. So let's do some practice. Let's find this, hint, hint, that, and property 2 up there. Let's do this one. That is a 2. Let's start there. Warm up. And honestly, the way this is rolling right now is a lot how class will roll. I'll get up, we'll talk about something beginning, and then we'll work together on it. And I walk around the room. I hope that's okay, because I'm going to do it. But if it bothers you being behind you, I will avoid being behind you. Just let me know in a kind email, not a terrible review. And then somehow I'm going to have to keep an eye on the time. Daniel time. So clean. Okay, cool. Awesome. You did a lot in a half hour. I'll come around. I'll check stuff out. If you think you're done, you want me to take a look at what you've done? Kayla, are you thinking? Yeah, take a look. So it's so beautiful. Now it's beautiful. Yeah, exactly. Well done. Anybody else want me to take a look at what they've done? Yeah, beauty. Quite beauty. You gotta check this. Yep, okay. I don't know what I thought. I saw something different. Lovely. That looks swanky. Peachy keen. That is almost. What were you tell me how you were thinking about that. Okay. So first off, let's look at the special case. So it's to take the derivative. We first copied the original problem down, and then times the derivative of the exponent. So the derivative doesn't happen in the exponent. So if we want to take, and let's put put a little parenthesis there instead of that equals.
Oh, in front of you?
No, just erase the equal sign. Yeah. You know what I'm saying? Cool, that's all right. Then we put, or that's cool too. So this is going to equal the e to the negative 3x to the first. Again, so we're going to now put equals to right here underneath or wherever you want to put it. Yeah, that sounds great. So now equals the original problem again, so put e to the negative 3x. And let's write this out times derivative times dx of the exponent, which is negative 3x. Yeah. So now how are we going to do the derivative of negative 3x? Because that is x to the first, definitely.
So it's just 1.
It's just a 1 there, yes, an unspoken 1. So let's put it in just so we can kind of. So now you're going to bring the negative 3 out front, you're going to forget about it. And then what's the derivative of x to the first? Yeah. So it's just that, it's a problem. Yeah, cool, so it'll just be e to the negative 3x times negative 3. Sound good? Okay, awesome. Paper is like making my eyes like go crazy. Yeah, it is. Yeah. It's beautiful. How are we doing?
Okay, I think
Quite good. I don't know if I like that exponent there. What happened to the negative 2? What's negative 2 minus 1? Beautiful. Oh yeah, there we go. Oh, so lovely. quite beautiful. Lovely. Cool. Yeah, absolutely. What am I doing, my friend? Peachy Keen. You were the Peachy Keen group. Oh, that's right. We've met before. Who haven't I looked at? Brendan, did I check here? Yeah, gorgeous, gorgeous. Have I not checked out anybody's work? Everybody feeling good? Cool. Well done, friends. Coming back to school is hard. We're gonna wake it up. All right, let's boost this up just a little. So those are kind of chill ones. I want to show you another. This kind of thing shows up all the time. So I had this Calc 2 class a semester ago or something. I tried to get those guys to write down these rules and have them by their side every damn day. And every damn day they wouldn't. Can you believe that, Alexander? Can you believe that shit?
Crazy, right?
So let's write these special rules and have them ready. These guys here, so in addition to these rules, I just want you to have these special cases ready. Because I swear, you're going to see them again today. So if I have derivative of e to just some multiple of x, like negative 3x, the derivative is just e to the kx times the derivative of kx, which is what? What's the derivative of kx with respect to x? K. So just a k comes out front. So now you got that e to the negative 3x, negative 3 comes out front. Quick. There's a couple other special versions of this. There is a sine of kx. That's the derivative, I'm going to do chain rule. Derivative of the outside is cosine, leave the inside alone, times the derivative of the inside, which is, we just did it, k. So k comes out in front. And then, let's just do the cos. Can you just do really quick? Do that for me on your paper, using this kind of following the rhythm, right? We're making music, making math music. What's the beat? Derivative of the outside times derivative of the inside. So it's going to be derivative of the outside is negative sine kx, and then the derivative of the inside is just a k, so a negative k comes out like that. Does that sound okay? Yeah, cool. All right, have these ready. I swear to God, I'm going to make you do them every damn day that we're taking derivatives. Okay, so your turn now, again. Sometimes it helps to read the problem in your mind. I'm going to recommend this to you. Let me give you a couple of my common spiels. Writing things is a technology. Mathematical notation is technology. This is how we help our brains. We don't have ChatGPT. We have these and this. And so to help us think and to remember and offload, we're offloading some of the process. We're gonna write stuff down, please. I'm gonna make you write stuff down. If you don't write it down on those little things, I'm gonna give it back to you and say, write more until you get a thumbs up. Okay, so derivative of x squared times e to the x cubed. Notice I said times. What rule are we going to need? Product rule, because it's times. Yep. Use the product rule because you wrote it down. It's not up there anymore, but you wrote it down. It's on your sheet. that's just gorgeous. Thank you. Oh, wait. So, let's see, so what you do. You took the derivative of that, left that alone, perfect. So, yeah, can you show, so this is great, I like that. And then something weird happened, can you scroll?
Oh, after.
Yeah, that was it. I think you combined those things weirdly, so.
Can you do it combined?
Yeah, what's wrong? There is something wrong here. What is x squared times 3x squared?
That was enough for us. Oh, wait, no,
Yeah.
that'd be addition.
Yes. Yeah, that's right.
I'd actually.
3x4.
There you go. That looks solid. Yeah.
Okay.
Work is
Wait,
good.
no, it should be, yeah, you're right. 'cause it should
Dropped
be
the ball
X
just in the
squared.
last moment
Okay.
there.
Yeah.
Feeling good, Talon?
Yeah.
I actually the third thing weird.
Oh, okay.
That first
Okay,
one,
cool.
or wait.
Well, the
So it's showing
X squared times.
Oh,
the
you
X
did
of
that
the
too.
is
Yeah, I
times
love that.
the
Okay, so we
root
both
of
have
X
this.
is-
left
And we
that
both
alone.
have-
And so we're doing,
Isn't 3x?
what's the derivative of x
Is it
cubed?
squared?
Because that's what
Oh,
should go.
yeah,
for
three
x
x
cubed.
cubed.
Yeah. That's what you're doing. That's good. That's good. I think it's going fantastic. Beautiful. Yes. Oh, and a factor and everything? What the fuck? That's awesome. That's so good. I'm gonna show everybody what you did there, Cormac. That's beautiful. That's beautiful. And so you can do it in either order too. So Brendan's just, Brandon. Sorry, I may change your E to an A occasionally.
It's okay.
You know who I'm talking
Yeah.
about. It's when I talk about Daniels that things are gonna get tricky. All right, looks good. Yes. So you should leave this one alone. You did this guy, you already did him. He's still x squared here. So here you took the x squared derivative. You see what I'm saying?
Yeah.
Cool, awesome.
It's gonna be so bad.
Good.
I don't understand.
And this is the only thing you didn't do, just take the derivative of the 3x squared.
I hope something was
So,
different.
I like this, so here you took the derivative of the x squared times the x cubed left alone, perfect.
I just can't sleep.
Then
Like, I'm
plus
not-
x squared left
Kinda
alone.
wild.
But we didn't
Yeah.
take that derivative.
That was good.
Oh, you did, you took it in the exponent.
That was
So,
kinda
can I
rough.
see if that's in real quick? Let's talk, yeah, so,
Dude, so
when we
like,
do
like
this,
last year though,
watch the
I had to
rhythm.
try and like figure out what to eat
Copy the
after
problem.
practice. Cause like the
Times
dorm
the
room,
derivative. So the derivative happens outside.
Yeah.
Outside, so
It's
the
like
3x
10,
squared
like,
is
oh, yeah.
times this dude again. Does that make sense?
No, cause I.
Yes,
I've always
absolutely,
kinda
yes.
like be weird
Yes.
myself,
Yeah.
but. So I always like. breathe
Yes,
into the cat.
quite splendid.
Shit, it's so bad, I'm trying to warm it up.
I'm not excited for after practice. It's
We're
like a shower.
good, yeah. So, let's do it together.
There's you and Gabe now. It's just two of you.
Yeah.
Watch me use the technology of notation
You can stay upstairs.
to keep my brain straight. And I just wanna emphasize this. Today, things are chill. But when things get hairy, you wanna go slow. It's like walking in the dark. You wanna watch what you're doing. You're walking carefully. We're walking mindfully, right? We're proceeding mindfully. So the first thing I did is I literally just wrote out the next thing. This is my plan. Now I just have to execute a much simpler plan. Take the derivative of x squared. You got it. Copy that down. Done. Copy that down. Awesome. What's that derivative? It's the original problem times the derivative of the exponent. Look how slowly I'm moving. If you find yourself missing derivatives, and you will, slow down. That is my advice from being freaking 58 years old, doing this shit forever. And teaching it for almost as long. And that's good. We could leave it there. And I'd be happy unless I said simplify completely. And then I would do a little bit of algebra, and I'm gonna do some of the algebra Cormac did. Now Cormac, being a math major, factored that e to the x cubed out because he noticed they both shared that. And what was left over was a 2x plus x squared times 3x squared, 3x to the fourth. That's a great answer. Oh, better.
Can't you also factor out the x?
Oh, yeah. Oh, man, are you just trying to push it? Buddy, you gotta take it easy on this first day, but yeah, I love it. Can factor it even more. Love it. Then if I were to ever ask you when this derivative equaled 0, we're not gonna do that today, but you could answer it a lot better now. Okay, good work. Any questions on any of that? No? All right, cool. We'll save the weird stuff for when you're nice and tired at the end.
It's just the boards.
Oh
I think
my
this
God.
one probably also does that.
What's going on?
The eat your meat.
Oh, sorry. Yeah, we thought. Yeah, what were you pointing over there for?
Oh, the board. I was wondering if this one also does that.
Well, I don't know. Let's try. Can you change my camera?
You don't have to change boards.
I know I don't have to. That's all right. We're not going to find out for a little bit.
Oh, it does. I heard different.
Too late. Your next problem, my friends. Derivative. Sorry, I'm not doing that on purpose. I'm like thinking. Go slow, like I did just a minute ago. Write the chain rule out. Write the chain rule out for safety's sake. Good news is with math, nobody ever gets hurt. So you can make a mistake, but practicing being careful. Chain outside in, work your way outside. There's actually 2 applications of the chain rule here. You have a long day coming up.
It's all that.
Is it?
It's all that.
Oh my God.
Your analysis.
What's on here?
Right before this one.
Oh jeez.
I end 10.
Oh my God. I'm super glad you're here, I gotta tell you. Anybody wants me to give them sanity check? Looks like I wrote some notes about stuff somewhere, and they don't seem to be relevant.
Nice.
No, they are. They're just pretty sparse. I think I wrote practice derivatives.
That's what I would do.
Yeah, that's, yeah.
Oh.
All right, sorry. Yes, sir. All right. All right, so let's see. So you did the outside left hand side long. I love it. Times the derivative of the inside. Dude! Yes, we have a parenthetical issue, but other than that, I love so this 2 doesn't go inside the outside. That's the only problem. You see what I'm saying? But that's beautiful. Nicely done. Nicely done. How's it going, Eric? You want to look at what's up?
Mine's just yours is better.
So quite well. Let's see, we have a minus
Inside
somewhere.
out.
So we did the derivative of the inside, that cosine. So what's the derivative of cosine?
It's a lot easier to keep track.
Minus,
Oh, yeah.
right? So somehow in there we need a little minus, yeah.
Yeah.
And maybe pop a paren around that, just
Yeah,
to
that's how you
keep
should
the
do it.
minus. So, yeah.
Yeah.
Beautiful.
Be careful. Relax.
Yeah.
Looks good. This is the minus.
I get it.
So let's see, so you did the outside, perfect, times the derivative of cosine. Derivative of cosine is minus sine, so you should have minus sine of 2x, and then still times the derivative.
What's it? Chain rule.
Now times the derivative,
need to
the
work
intermediate.
on
So you still gotta get that 2x. Does that make sense?
And then
That
till next semester.
looks beautiful. Love it. What's that?
It's like-
Oh, I see.
but it
Cool.
wasn't like, yeah, of course.
Reorganize. Oh yeah, it's good. It's good. It's good. It's good.
Class.
It's good. Yeah,
Oh,
yeah.
no.
It's good. It looks uncertain, but good.
Yeah.
Okay. Why?
That's just how my schedule worked out.
Oh, I was like,
All my classes, like, all those were 1-hour classes.
Yeah.
Do you have like any classes tomorrow?
No, I have no classes tomorrow. No.
What's the next?
Where was it?
It was the pizza professors at Carroll,
You got
whatever that department is.
Oh, is that the math, the amp
Yeah.
department? Okay, that's where it was. Okay, cool. All right.
I still gotta show up though.
That's true, yeah. I got lab on Thursday. That makes you feel any better.
Check. Love it. Check. Yeah, it's already, you got to check one.
Same as
Besides physics.
Good work. Okay, cool.
Says what?
Good work.
Oh, yeah.
Let's do some more. What time is it?
2:50.
2:50. Oh, we've got forever. Forever. All right, so, ooh, I think we need more chain rule practice. Absolutely. Natural log of e to the sine of x squared. Wow. You know it.
Hell yeah.
Hell yeah. Now we're cooking. Go slow. Use the special chain rule for the log that I gave you, that you wrote down, that you have on a sheet next to you, that you use all the time.
Did I write it down?
Sometimes I use that fill in the blank notation. Never see anybody else do this. I like it, and I think a lot of people do. Sometimes it can help make thinking easier. Yeah.
Oh, you just go to the same one?
Yeah.
Oh, yeah, right here. Yeah, I see.
Oh, sorry, it's here. Yeah, okay, I was looking at that.
Oh,
and
no,
that
that
was
was just my
scratch
work
work.
to
Okay,
do.
yeah, that's beautiful, yeah. Ooh. What's the rule for log?
Freak me out when I see a log.
So does it have a log at the bottom?
It's x squared inside.
And no absolute value?
Put 2x.
Yeah. Does that make sense?
Mhm.
Cool, that's good.
Just Sine x squared. Yeah, you don't do the derivative of it, it's x squared, it should be still be x squared inside of it. Because that's the point of taking it out.
Oh, I see. Oh, how interesting.
Well, no, but like,
Okay, so let's see.
wait.
You don't do the derivative inside the cosine.
Oh, that's so right, yeah.
Yeah, it got a little too, oh, wait, no, maybe it does do that. Jeez, wait. Let me go work it through.
What happened?
Like, that was just like, I didn't know what it was. I was learning that shit during COVID, so she was like,
Yeah.
might as well have not learned it.
Oh, yeah, I think you're right, Kayla.
Whoa.
Yeah,
It does cancel out.
it does cancel. That's,
Not the whole thing.
oh, and then let's talk about why in a minute, but yeah, it should, yeah, duh, when I look at that. Why kind of a duh? Yeah, because natural log and e are inverses of each other. So the natural log of e is, yeah, we'll talk about that in a second. But let's just do it this way. What the hell? So we're checking it out. So the bottom, just copying it down. Derivative of the top, we're going to use this rule. And you might want to write it this way, especially if it's been a while. If you've always had function challenges, this is a good way to get around that, thinking in these template rhythms, thinking in rhythms like that. So it's the original problem times the derivative of the exponent. Yeah? Just feel okay? Okay, everybody hang in there. We're almost through the first day of Calc 3. I know it's late. I know it's a lot of math. We got this. So what's going to happen is these two are actually going to cancel because that's just a product on top. And so it's the derivative of the sine of x squared, which is the derivative of sine, inside left alone, times the derivative of the x squared. And so we just get, I'll put the 2x out front. Ooh, let's have a fun math talk. I didn't even know it was coming. This is cool. So why? So first off, the natural log of e to something is just that something. It's like one of the ways we define natural log is it undoes e in some ways. So these two functions are inverses of each other. So this expression here, why can I get rid of the absolute value? So why is this this? Why can I just throw away the absolute value? Anyone can tell me. What is that? So what I do here is I'm saying that this original problem, I wrote the absolute value here, and I'm saying you could throw away the absolute value. Why? Yeah.
Is it because no matter what x is, e will be positive?
Absolutely. E to some power is always positive. Right? Think about the graph of e. E to the x looks like this. It's always above. So e to the x is always positive, unless you take complex variables and then things get crazy. But for us, for everything we'll ever do in this class, it's positive. So this is actually a positive quantity. So I can get rid of those things. The absolute value of a positive is itself, the thing itself. And so we got this, and so then we could have just gone to this. So that was a bit of a boneheaded problem. I could pretend like I wrote it for that digression there, but I already told you I didn't write any of these ones. Is there anything, how are you feeling so far? Let's just do a couple more. We can even let out a little early today. We'll be all right. Hey, by the way, what's the thing you should be doing when you, between now and Wednesday? Just let's see.
Sleeping.
Logging into web work. Sleeping. Did someone say sleeping? I thought someone said sleeping. Maybe I was thinking that. Web work. And we're going to start the web work, right? We're just going to get in there. There's just a bunch of basic derivatives. On Wednesday, we're going to do integration. We're not going to do that today. Today's just basic derivatives. Wednesday's integration. And then Friday is come in and work day. And we're going to like wrap stuff up. You can bring your web work in, but start it before then. You don't want to do web work at the last minute. But wouldn't it be sweet if we could get it done before the break? Wouldn't that be sweet? Yeah, I think it's sweet. It's not even for a grade, right? Yeah, and it's not even for a grade, but just to like know, shit, man, I got all my Calc 3 done, and now I got a 3-day break. All right, so let's see. Cameraman, can you bring it back over here, please? Hi, we're back. How could we do this? Let's have a chat. Oh, yeah, look at this. So I could rewrite this as the derivative because it's like, what is tangent? I don't know, but I sure know sine and cosine. And Alexander, just regaled us with an awesome identity. And then let's do the quotient rule on it. Let's do that. And then you'll get an answer that'll be a fraction. Can you convert it into one of the weird trig functions? The other three does. Yeah, one of those. Bizarro world trig functions that nobody ever uses. See, if Dr. Chamberlain were here, she could tell me, she'd say, actually, we use it all the time in chem. I take the cosecant stuff left and right. Write it out. Use the notation, because there's some signage that can get you confused. And those shoes are wild. Those are awesome. Man. Those cool shoes are sick.
No, there are the skateboarding shoes.
Oh, wow.
Yeah.
Let's see what you're about. Yeah, beautiful. So can you think of like how to convert that? So there's sine, cosine, and tangent, and then there are the other. Which is how does it work out in the other three? And then we'll get like a well-known formula for it.
I would look at this. I would
Splendid.
not have that.
Think trig identity for the top.
Because
Oh.
Aha!
Cosine times cosine is cosine squared.
I was thinking that, but I couldn't remember which one until that.
Yeah, now you got it, right?
It's time.
The chief, the queen of all the identities.
So it's negative, or it's just sine
Here.
Yeah.
We're thinking, awesome, hey, that's all I ask. That is all. It's,
Show me what you've written.
Or
Like
equals one.
further?
I don't know if that's a trig identity.
Oh, yeah, I don't know that.
Isn't it?
Yeah, so
My
this is
recollection
cosine
of trig
squared
identities
plus
is like.
I also did that during
with
COVID.
That's what actually, oh, yeah, the same with me, actually.
Cosine squared plus sin x.
looking good.
Sine squared x.
Solid.
What do you have like a cheat
Yeah.
sheet?
Like,
Two quotients is actually.
This is like my shit from the last time.
Oh, from like high school?
Yeah. I don't know if I still have.
Oh. Wait, that's.
Oh, sin squared is one minus cosine two A. Which is
Let's
One thing I'm seeing as I walk around is a lot of really good work, like right work, but notationally needs a little improvement. So I'm gonna recommend using more parentheses to all of us. You can always add more, but you can sure screw yourself up if you don't add them. So notice how I put that derivative of that thing, har, or what, I don't know what language I'm speaking there. But notice here how I put that in a paren, so I didn't think it became like anything else. I didn't think it was a minus, I don't know. Anyway, enough of that.
Yeah, I don't know. I have no idea.
Yeah. Cosine squared plus sine squared is 1. Let me prove it to you. You've seen this last semester, maybe.
Yeah, I was
Yeah.
like, let's take that out.
We got something though.
What's the, if that's right triangle, what's the Pythagorean theorem say? Yeah, cool. Or h squared, yeah, could put an h, yep, but I had an h, yeah, right? Okay. Let's divide through by h squared. Let's make this look like a over h. Let's give this an angle. What is a over h relation to that angle theta? So A over H, this ratio, that over that is the what of cosine of theta. So this is cosine squared. What's B over H ratio? Sine, so we got sine squared of theta equals 1. So there's a quick little, not a math, that's not a mathematician's proof. Like if my colleagues saw that, they'd be like, yeah. But it's heuristically okay. We can get a bunch of others if we want. So, oh, let's do this one. This is what in terms of the other three? Secant squared. Yeah. So you can kind of get some other ones. If you divide through here by cosine of x, just want to show you how you can get a couple others. You might need them at some point in your life. So this is what here? What's this guy? Tangent squared. And then we know this guy's secant squared, right? So anyway, this is just probably one of the greatest identities in the world. It's just sweet. You can do all sorts of stuff with it. Now what time I got, Daniel? You have become Lou. Jeez.
It's 3:07 right now.
3:07. Let's call it. Good work. That's a lot for a first day. So you're gonna try to log into WebWork, and if you can't get in, you're gonna email me, tTrenery. Oh, my YouTube page, if you just look up
I think I am subscribed.
on YouTube, give me a follow. I'm not monetized, I'm not trying to make money off you, but I have some merchandise. What's that, how many?
5 million.
What? No, God. And no likes? What the? And feel free to like a video. God forbid anyone like any videos I ever post.
Like and share this.
Yeah, there you go.
You gotta go to the camera, you gotta-
Oh, 100%, yeah.
Exactly.
Some like the later ones, like towards the end of the semester.
You heard it.
I got merch.
What was that?
Call up the merch man. Call up the merch man.
Hey, thank you, Czar. All right, thanks,
I was
friends.
using some of them from